This video looks at some applications of integrals with particle motion or gravity. So I just want to look at a couple different ones and how to read them. So a penny is thrown downward from a 300-foot tall tower with an initial velocity of 50 feet per second. When does the penny hit the ground? So on Earth, gravity is always the same. It's negative 32 feet per second squared. So we want to, which is acceleration due to gravity. So we know our acceleration. So in other words, we know that the second derivative is negative 32. What other information do we get from here? Well, we have initial velocity of 50. That means f prime of 0 is 50. Now, it's being thrown downward, so we make that negative because it's going towards the ground. And we know that the initial height of the building is 300. So it's helpful to have all that information because when we integrate, that's going to help us find c. So the integral of negative 32 dt, that gives us the velocity. Integral of negative 32 is negative 32t plus c. That's where we can use our initial velocity of negative 50. So since it's 0, we know that c is just going to be negative 50. And so the next thing we can figure out is how to find displacement, because we're trying to find when it hits the ground, so we need to know an equation so we can find out when the distance is 0. So we integrate again, and the integral here, we get f of x. Integral of 32t is negative 16t squared. If you've had physics, you recognize that. Minus 50t plus c. Well, again, our c, our initial height, if they ever give that to you, you can just plug that in and go. So our initial c is 300. So basically, we're starting at 300, and both the velocity and acceleration are decreasing our speed. So if we want to answer the question, when does the penny hit the ground, we set the height equal to 0 and go about factoring or using your calculator, quadratic formula, whatever. So I'm going to go ahead and trust that you can factor this and solve. You're going to get one positive root, one negative probably, because we're launching straight down, which means the other side of the parabola is going to give you a distance of 0 over here. You won't use that negative value for the other side. So continuing on to number 11 here, a ball is thrown straight up from the ground with an initial velocity of 96. That means f prime of 0 equals positive 96. Find the ball's maximum height and the velocity when it hits the ground. So again, we start out with acceleration equals negative 32. That means if we integrate, velocity equals negative 32t plus c. Well, c is 96. So we can actually answer or get part of the answer for our maximum height here if you want to. The maximum height is when the velocity is 0, because you're throwing a ball up in the air. At 0 is when it's at its maximum. But we want to keep going. Take the integral. Integral of velocity is displacement. You can use f prime, those things too. Negative 16t squared plus 96t. Initial height, since it's on the ground, is 0. So here is your displacement. You can either find the vertex of your parabola and figure out the maximum height there, or you can set your velocity equal to 0. So negative 32t plus 96 equals 0. So 32t equals 96. So at t equals 3, we get our maximum. Plug that in here for t, and that'll evaluate your height.